Hi Coach L, this is the tutorial for using a sound detector board. Let's go. This is the basic code for using the sound detector board. We're going to use the sound detector to measure the volume of the surrounding area and change the color of the RGB LED based on that volume. So first we're going to use the constant integer function to define the pin variable. So red pin is 5, green pin is 6, blue pin is 9, and the sound pin is going to be an analog input of 0. Then we're going to create variables for storing raw sound in a scaled value, so sound and scale integers. Then we're going to start the serial port at 9600 bps, so the serial begin function here. Then we're going to set the RGB pins to output, so using pin mode. So pin mode, red pin output for green pin and blue pin as well. Then we're going to void loop. And we're going to read and store the audio from the envelope pin. So sound equals analog read sound pin. And then we're going to do map the sound from 0 to, which in the quiet room or clock is 300, from 0 to 3 to be used in a switch case. The scale is set up for using a switch case. And we need to map a large set of, where we need to map a large set of numbers down to like 3 or 4 choices. And a switch case is helpful in this scenario because we're gonna be taking a really long chain of statements, if or else statements, and condensing it into a simple switch and chain code. So yeah, and then so when we go to the print values, we're gonna print the sound that's from up here. We're going to print a space, and then we're going to print the scale from what we get from mapping the inputs to the four variables. So then we're going to do the switch case code here on a scaled value. So case 0, so if 0 RGB, the RGB will equal blue. So digital red pin low, green pin low, and blue pin high. We're going to delay for 500 milliseconds, and then break. So each case has its own break command, which allows the Arduino to escape out of the switch case and then continue on its way down the code. So for case 1, if 1, the RGB is going to equal green. So using the digital write functions here, we're going to set the red pin to low and the blue pin to low, but the green pin to high. Delay again for 500 milliseconds, and then use the break command here again. So for case 2, if it's 2, the RGB will be yellow. We're going to do the digital write function again, so the red pin will be high and the green pin will be high, creating a yellow light out of the RGB LED, and the blue pin is going to be low. We're going to delay again for 500 milliseconds, and then use the break command again. For case 3, the RGB is going to be equal to red. So using the digital write function again, the red pin will be on high and the green and blue pins will be on low. We're going to delay for 500 milliseconds and then use the break command. So then if the numbers don't correlate to any of the cases, then we're going to go to the default mode. So default is going to just turn off the RGB LED. So using the digital write function, we're going to set the red pin, the green pin, and the blue pin all to low. Delay for 500 milliseconds, and then use the break command again. And that's going to loop through the different inputs of sound. And so then if we go to the serial monitor, we can see the inputs as we change the sound. So right now, when it's 0, the LED will be blue light. We got 3, we got red. So yeah. Changing. This is the basic Arduino board for the basic code of using a sound detector board. So here we have the RGB LED. The red pin here and the green and the blue pins here are run through a 100 ohm resistor, and the red pin here is connected through this orange wire to pin number 5, and then the green pin is connected through this green wire here to pin number 6. And then the blue pin for the RGB LED is connected to this blue wire to pin number 9. The RGB LED is also grounded by this black wire here, which connects it to the negative column, which is grounded by this other black wire right here, which grounds it to the ground pin on the board, Arduino board. And we get down to the sound detector board. So the sound detector board has three signals for the outputs. And so the first signal is the gate, which is you can see right here, which is the digital signal that turns on when the ambient sound passes a certain threshold. So we see the red LED here. That turns on when the sound detector board detects when it's loud, and it goes off when it's quiet. So the second signal is the envelope, and that scales the amplitude to a 0 to a 1023 10-bit value. And the envelope output on the board is used to measure how loud it is in the room. So then the third signal is the raw audio signal, which is here. And in a quiet room, it levels out at around 512 and will create a waveform curve that's based on the frequency of the ambient sound. But that can be used when you get deeper into the how to use audio files. So it is grounded. So on the board, it is connected by 3 wires. So it is grounded by the ground pin through this black wire to the negative column, which is grounded by this black wire here. And then the orange wire here connects to the VCC pin, which connects the board to power, which is 3.3 volts. So it connects it to the positive column through the red wire to 3.3 volts pin over here. And then this yellow wire connects the envelope output on the board to the envelope output on the board to the analog output pin right here. So that's how that works. So now it's not doing anything. So let's see if we can get it to change the colors. There we go. I got up to yellow, but there we go. This is the modified code for using a sound detector board. We're going to use the sound detector to measure the volume of the surrounding area and then change it to the color of the RGB as well as the orientation of the servo motor based on that volume. So first we're going to use the constant integer function to define the pin variables. So the red pin of the RGB LED will equal 5, will be connected to pin 5 on the Arduino board. The green pin of the RGB LED will be connected to pin 6 on the Arduino board, and the blue pin of the RGB LED will be connected to pin 9 on the Arduino board. And then the sound pin will be connected to the analog pin 0 on the Arduino board, there. And then we're going to have variables for storing the raw sound and scaled value. So using the integer function of sound, we're going to store the audio directly from the soundboard, and then the scale, we'll use a scale integer to store the mapped value of the sound. Then we're going to include the servo library here. And Arduino libraries are collections of pre-written code that allow you to perform complex actions simply and faster. Instead of researching like how each piece works and how to code it onto the Arduino, you can just use the pre-written code. Then we're going to create an object called servo1 here. And then in void setup, we're going to start the serial port at 9600 BPS by using serial begin 9600. That's going to be used for the serial monitor. And then we're setting the RG pins to output. So set the red pin of the RGB to an output so it will receive information, and the green pin as an output, and the blue pin as the output using the pin mode function, so they'll all be able to receive information. And then we're going to attach the servo1 to pin number 3 on the Arduino board. We're going to create a local variable called position using the integer function to store the servo's position. And then we're going to use the analog read function to read the audio collected by the envelope pin and store it as a sound integer. So the sound pin and store it as sound here. And then we're going to use this map function to use the sound numbers collected from 90 to 400 and map them to 0 to 3 as a scale. So we're going to translate those numbers to 0 and 3, and I raised the number from 90 to 400 so it filters out more of the background noise as well as having a higher bracket for each of the cases. We're going to print values over here, so we're going to use serial print dot print here. So we're going to serial print the sound, so that the raw sound collected from the board, and then we're going to print a space, and then we're going to use serial print again to print the scale of the 0 to 3 number. And then we're going to have switch scale here because it's going to have the switch cases based on the value of the scale of 0 to 3. And then for case 0, we're going to have the RGB LED be blue and the servo will be at 45 degrees. So we're going to use the digital write function here to set the red pin to low or off, the green pin to low or off, and the blue pin to high or on. And then we're going to use servo1.write45 to tell the servo to go to 45 degrees. And the serial print here to print a space. So we're going to print out what's going on. So print a space, serial print red pin off, serial print a space again, green pin off, print another space, blue pin on, another space, and then tell the servo, and then serial print ln. So we're going to say the servo is going to 45 degrees and then print a line underneath. So it's going to turn a line on the serial monitor. We're going to delay 500 milliseconds to pause for the light on and the servo motor to pause in its position. Then we're going to use the break command to allow the Arduino to escape the switch case and then continue. Take more readings. For case 1, the RGB LED will be green and the servo motor will be at 90 degrees. So we're going to tell the red pin, using the digital write function again, to be on low or off, the green pin to be on high or on, and the blue pin to be low or off. Using the servo.write90 again to tell the servo to go to 90 degrees. And we're going to print out what is going on, so we're telling to print a space between what we printed above, which was the scale and the scale here. So it's going to print right after the scale. We're going to tell it red pin off, print a space again, green pin on, space, blue pin off, space again, and then servo equals 90 degrees. And using the serial print ln is going to return to the next line, delay for another 500 milliseconds, and use the break command once again. When we go to case 2, here, the RGB LED will be yellow and the servo will be at 135 degrees. So using the digital write functions again, the red pin will be high, the green pin will be high, so those two will be on, and the blue pin will be low, turning the blue pin off. And the servo write function, we're going to tell the servo to go at 135 degrees, and we're going to use the serial print functions again. So telling the red pin's on, the green pin's on, and the blue pin's off, and the servo is going to 135 degrees. Delaying for another 500 milliseconds, and using the break command once again. For case 3, the RGB LED will be red and the servo will be at 180 degrees. Again, using the digital write function here, the red pin will be on high or on, and both the green and the blue pins will be on low or off. Using the servo1 write function, we're going to tell the servo to go to 180 degrees, and then again doing the same serial print code here. So the red pin will be on, green pin off, blue pin off, servo equals 180 degrees, pausing for 500 milliseconds, and then using the break command again. And then we're going to go using default. So if the match to the cases is not available, so if the sound is too low for the case or too high, then the default setting will be used. So the RGB LED will be off, and the servo will be stepping to 100 degrees up and then back down again. So using the digital write function, we're turning the red pin low, the green pin low, and the blue pin low, so they're all off. And then we're going to have the motor step up to 180 degrees by 2 degrees. So for position when it equals 0 or less than 180, the position is going to increase by 2. So it's going to go to 180 degrees and by stepping by 2 degrees. So then here we're doing servo1.write position. So that's going to move it to the next position and then delay for 20 milliseconds, allowing it to move. And then once it gets to 180, it's going to step back down by 1 degree. So for position equals 180 degrees and greater than 0 degrees, it's going to step down by 1 degree. So then we're going to have the servo write position, so it's going to move to the next position and then delay for another 20 milliseconds between each position. And that's all going to get printed onto the serial monitor. So red pin off, green pin off, blue pin off. So the RGB LED will be completely off, and this is going to print servo stepping to 180 degrees and down. So it's going to show that it's going up to 180 and then down again. And then we're going to delay for 500 milliseconds to pause when the LED is off and for it to move. And then we're going to use the break command once again to allow the Arduino to escape that command and continue taking more readings. So if we go to the serial monitor, we can see it working. It's taking, as I'm talking, you see the change here in the numbers of the raw file, and it's at the 0, so the blue pin will be on, so case 0, and the servo will be at 45 degrees. If we create more sound, it'll change the raw sound here, so if we go, if we can get it up to a red. See, if we go too high at 4, case 4 and 556, which is over the limit, then you see that it stepped by 180 degrees up and down again. It's back to there, and let's see if we can get up to 4. And it does go to red, but I just can't seem to get that sound, that specific number right now. So they keep going over. But there we go. So here is the modified board for the modified code of using a sound detector board. So here we have the sound detector board. It's set up the same as before. We have it grounded by the black cord here on the ground. The VCC is connected by this red cord here to 5.5 volts through the red wire. And the envelope is connected by this yellow wire here, this yellow wire here, to the analog read function. Then we get up to the RGB LED, the red pin, and then the green pin and the blue pin go through these 100 ohm resistors and are connected by these wires. So the red pin goes to the orange wire here into pin number, here we go, number 5. The green pin is connected by this green wire here to the digital output pin of pin number 6. And then the blue pin is connected by this blue wire to digital output pin of 9. And it is grounded, the RGB LED is grounded by this black wire here into the negative column, same as the board, through this other black wire into the ground pin on the Arduino board. Then we get to the servo motor here. Here it is. So the motor here is connected by this white wire to the pin number 3 on the Arduino board. Is connected to 5.5 volts through this yellow wire, which is connected to the positive column here, which is also connected to the red wire here that connected the sound detector board as well to the 5.5 volts on the board. And then it is grounded by the black wire here, connecting it to the ground pin on the Arduino board. So right now we can see that it is on case 0, and if we try to bring up, there we go, it moved to 180 degrees. If we try to, here we can see, as it runs through the different, that it was too loud, so it went to 180 and back to 180. Back. So I think that's all the colors. So, and there we go, it's working. So the change in the LED, and then it changes the position of the servo motor. There we go.